Good morning, class. Myself Karthikeya Kushal Kumar, and I am from Vizag. I have done my BTech from the NIT Calicut Electronics and Communication Engineering. I have given GATE in 2025, and my hair rank was 79. And after that, I have joined in IIT Madras and BLSA. And after I got job in NPCL, I have been dropped out from IIT Madras. Right now, I am an executive trainee. After a few months, I have been promoted as a scientific officer. In the meantime, in my training, I have started this YouTube channel, Nucleopedia. In this channel, I will briefly discuss about various topics related to the nuclear engineering, and the mode of the language, it will be both English as well as Telugu, and there will be different videos for the English as well as Telugu. No need to take tension on that. Depending upon your preferences, you can watch either English as well as Telugu. So the main objective of this channel to share my knowledge about my nuclear engineering to everyone through this channel, Nucleopedia, and bear with me max 10 to 15 minutes with my bad English as well as with my bad jokes, because of that many girls left me, but don't left me here. We will discuss more good topics, and we can have interactive sections as well as it will be too good. From coming classes, I will be more interactively. I will want to teach better way, so I will be learning that. It is my first class, so please bear with me. So we will start the section. The part 1, which is the differences between the coal-based thermal plants as well as nuclear power plants. So what is meant by a power plant? Okay, just leave it here. What is meant by power plant? Power plant means which generates electricity. However, electricity has been generating from a thermal plant. So this is the principle which has been used in the daily life only. For example, if you are seeing a motor, whenever an electricity has been given to a motor, what happens? The motor will rotate. So it is an opposite principle of the motor. Whenever the motor rotates, it generates the electricity. Same principle we have been using in this the power plants. But to rotate the motor, we require some high pressure steam. To get the high pressure steam, we are using these boilers. We are using these boilers. These boilers, because of these boilers, there are different type of because of the differences, we are having different type of power plants, which is coal as well as nuclear, as well as there are gas based power plants and different type of power plants. But here we are using a coal burners. Here the coal has been using as a fuel. Whenever the coal has been dumped in the coal burners, the coal burns. Whenever the coal burns, it generates what? Heat energy. This heat energy has been used by the water, and the water has been converting into the steam. Whatever the steam which is been generating from this is having a high pressure steam, which can be used to rotate the turbine blades. The turbine contains blades, and the turbines having two different types. There are different type of turbines. We will go on the next classes. We will learn on it, but mostly there are impulse turbine as well as reaction turbines. So we will discuss it in other classes, but we will stick to this topic. Whatever the high pressure steam, it strikes the turbine blades, so it rotates the turbine blades. Whatever the turbine blade rotating, it rotates the shaft. The shaft is being connected to the generator. What is meant by generator? Generator converts the mechanical energy of the shaft to an electrical energy, and this electrical energy has been given to the grid. What is meant by grid? Grid is a central point between the power plants as well as consumers. So this is how the coal-based power plants will be working. So I will give you an overview of the coal-based. For example, the coal has been dumped into coal burners, and we are burning the coal, and whatever the coal burning, we are generating, and heat energy has been generated, and this is supplied to an water, and the water boils, and whatever the water boils, the steam will be getting a high pressure steam, and the high pressure steam used to rotate the turbines, and the turbine has been connected to the generator, and the generator will gives the electrical energy, and it is supplied to the consumers. This is how the coal-based power plants has been working. And coming to the nuclear power plants, what is the difference between the nuclear as well as the coal, and what are the advantages we have been seeing in this nuclear power plant? We will be discussing now. So nuclear power plants has been categorized into the two sides. One is primary side as well as secondary side. Secondary side was common, same as the coal-based power plants also, but primary side was the different. Primary side, we are here is the primary side is reactor building. What is a reactor building? Reactor building. Reactor building, the building where the nuclear reaction takes place. Here it is not a nuclear reaction. We are burning the coal. Here the coal act as a fuel. But in coming to the nuclear power plants, uranium act as a fuel. Uranium act as a fuel. So by having the nuclear reactions, we are generating the heat energy in the nuclear power plants. The heat energy which is being generated can be used to provide the steam, and the steam is been goes to the turbine, and the same process which is being in the coal power plant is been same as in the nuclear power plants. But how the nuclear reactions has been happening in the reactor building? For suppose there are two types of nuclear reactions. What are the two types of nuclear reaction? Fission as well as fusion. What is meant by fission? What is meant by fusion? Fission means whenever a nuclei has been split into another two nuclei is known as fission. What is meant by fusion means whenever two nuclei has combined to form a single nuclei. The main difference is fission means separating. Fusion means combination. Combination of two nuclei into a single nuclei is known as fusion. Fusion means separating. This is the difference between the fusion and fusion. Another main difference is fusion cannot be controllable. Fusion can be controllable. So we are using the fusion in the reactor building. Nuclear fusion reaction. This is an example of a nuclear fusion reaction which is take place in the nuclear power plants. And uranium act as a fuel. I have said whenever a uranium has been bombarding with a neutron, proton, electrons. We will discuss this about the atomic structures in the upcoming classes. But right now, understand it. I will briefly explain in the upcoming classes. But right now, understand whenever a neutron is being bombarding with the uranium atom. Whenever it is bombarding with uranium atom, the uranium nuclei has been splitting into the two other nuclei. The splitting parts can be taken as in fission fragments. This is not that much important. It is also important, but in other senses. But right now, the important parts are energy which is being generated by the nuclear fission reaction. This is the nuclear fission reaction example which is being taking place in the reactor building. This is the energy which is being generated by the nuclear fission. This energy has been used to boil the water, and the water which is being generated has been passing into this reaction. By observing this energy, the water has been converting into the steam, and the steam flows to the turbine, and the same process will be repeated. So how the energy has been generated whenever a neutron has been bombarding with the neutron? This energy is a binding energy, is in the form of binding energy. Binding energy has been converting into the heat energy. So what is meant by binding energy? For example, a atom is there, an atom having electrons, protons, as well as everything is being there, but it is binded. Here the nucleus, here the electrons has been present here, but it is in been binded. But whenever a neutron strikes here, this nuclei becomes unstable. Because of unstable, it is being split into the two other nucleus which can be stable manner. No atom or no nuclei can be stayed at an unstable region. So it wants to make into a stable region. This is the small example of how the reaction has been taking place in the nuclear reactors. So it is in primary side, it is in secondary side. Why it is in primary side? It is in radioactive side where the reactions takes place. It generates alpha, beta, gamma, as well as many neutrons has been generated. These are radioactive materials. It causes ionizing radiations, different type of radiation which causes hazardous materials, which is hazardous to our body. So it can be treated as a primary side. It is taken as secondary side. But what is the advantages with the nuclear power plant compared to the coal-based power plant? Coal-based power plants generates more CO2 emission compared to the nuclear power plant. NBPs are better net zero emissions. They are not at all generating. They are generating very less amount of CO2, but it is very less compared to the coal-based power plants, other based power plants, hydrodynamic as well as any other. But NBPs are better, as well as 1 kg of uranium-U35 releases approximate energy equal to the energy produced by burning 3 to 4 million kgs of coal. What is meant by the point means, burning of 1 kg of uranium generates how much of energy is equivalent to the 3 to 4 million kgs of coal. If you burn, how much of energy they are two equal. For example, 1 kg of uranium, how much energy it is being generated is equals to the energy produced by burning of coal 3 to 4 millions of coal. 3 to 4 million kgs of coal. You have seen the differences, right? 1 kg as well as the 3 to 4 million kgs. The numbers. This is the energy is being generated by small amount of uranium. So you can imagine how much energy it is being generated from a small amount of uranium atom. As well as coming to the, as a myth has been generating in the whenever a nuclear power plant coming, there is a radiation can be occurring from the nuclear power plants. As my father is also asked me when I am joining in the NPCL that there will be radiation problems can be happen, but I am sure that there will be no radiation problems, because whatever the radiation which is being generated from the NPPs means nuclear power plants, is 1 millisievert per year, which is 1 millisievert per year. What is meant by millisievert? It is the unit of the radiation dose. We will discuss in the upcoming classes, but right now stick to it. What is the units for the radiation is 1 millisievert per year. This is the radiation which is coming from our nuclear power plants. But what is the natural background radiation which is being occurring to our body means, what is meant by natural background radiation is what we are eating, the radiation which is generating from the sun, as well as what we are inhaling from the walls we are getting the radiation. The total radiation which is from the natural background radiation was 2.4 millisievert per year. This amount of radiation has been coming from the natural background, so it is much more higher compared to the nuclear power plant. So that we can determine that NPPs are safe and reliable to use and can generate more electricity with net zero emissions. This is it, the main difference between the coal based as well as nuclear power plants. I will give you an overview of the differences. Here the coal as in fuel, here the uranium as in fuel. It generates more electricity compared to the coal, and with having a net zero emissions as well as less emissions into the air, and it was the best. And if you are having any doubts, we will stop the class and we will upcoming classes we will learn more about thermal fundamentals, as well as generator, how the generator works, as well as nuclear physics, how the nuclear reaction has been taking place. And the main points here I forgot it. Here the neutrons has been generated, right? Here the neutron, whenever it is bombarding, it creates a fission fragments as well as an extra neutrons. These extra neutrons are helpful for the chain reaction. Note that point, chain reaction. It is a main topic in the nuclear power plant. We will discuss about it in the upcoming videos. It is much more important. We will discuss in it, as well as whatever the notes I prepared it, I will share it in the description about Google Drive, so you can watch it and you can write the notes about it, because it is something clumsy here. So I will provide the notes, no need to worry on it. So let us end our section today. Thank you guys. Bye bye. See you in the next class.